Good afternoon, Build Stuff, and welcome back to the AC/DC virtual stage. I say good afternoon. This is, of course, an international conference, which means here in 2020, we got people tuned in from all kinds of different time zones. So our next speaker is beaming in from 5 o'clock in the morning, where it is in Seattle, Washington State. He is a cloud developer advocate. He's a member of the League of Extraordinary Cloud DevOps Advocates. Is currently working with Microsoft, doing all kinds of stuff with cloud advocacy, process consultancy, helping teams all over the world embrace the cloud and do stuff better with it. Please give a big Build Stuff AC/DC stage virtual welcome to Abel Wang.
All right. Thank you all so much. I am so excited to be here to talk to you guys about real-world DevOps. But before we begin, I wanted to show you all a real-world disaster story, right? So before I do my talks, usually I always, check my demos really quickly. And like they said earlier, it's really early right now for me. It's like around 4:46 a.m. So I got up around 3 o'clock or 3:30, and I said, I better check my demo, see if it's working. And this is what I ended up seeing. Okay, maybe I need to refresh that. Okay, that doesn't look good, right? However, all of my resources, they're hosted in Azure. So maybe I'll check my resources in Azure, see what's going on. And, all right, let me refresh. Okay, there's no resources. So apparently somebody has come in here, some idiot has come in here and deleted everything right before I have a presentation. And that idiot, it probably was me. I was cleaning out all of my resources in Azure. I have a lot of subscriptions, and I think I just chose the wrong one. However, I should be okay because when I built out my pipelines, I used DevOps best practices. So what that means is I should just be able to kick off a release and it should do everything for me because I use things like infrastructure as code. I, do disaster recovery. I do all sorts of stuff in my pipeline. So again, in theory, the pipeline should kick off. It should provision everything that I need. It should then deploy my demo back into my environment and configure everything and restore data, do all that stuff. And by the time I'm done talking, hopefully it'll be up, done, and working. So I'm going to let this run in the background, and we'll go ahead and jump back to my talk. All right, so quick introduction. My name is Abel Wang. I'm the Principal Cloud Advocate and the DevOps lead here at Microsoft. I've been writing code now for, I guess it's over 20 years. I've been doing this for a really long time. And I'm super lucky because right now I lead a team of 5 DevOps practitioners, and our sole charter is to help everybody get into Azure using DevOps best practices. Now notice, I didn't say you had to use Microsoft tooling, right? I didn't say you had to use GitHub Actions. I didn't say you had to use Azure DevOps Services because Azure is an open system, which means you can use whatever tooling you want, right? But we are here to help everybody get into Azure using DevOps best practices. Those are the most important things, right? So we're a resource. Please use us. How do you get a hold of us? Don't email me because I hate email and I'm like about 2 or 3 weeks behind. So I have thousands of unread emails. But if you want to get a hold of me, I'm on Twitter all the time. So if you tweet at me and hashtag it LOECDA, that will literally light up a team room. We will see it. We will answer your questions. And if I can't answer your questions, I will find the people at Microsoft that can. So again, I'm a resource. My team, we are a resource. Please, please do use us. All right, so DevOps. Clearly, I'm very passionate about it. And today I want to talk about real world scenarios about DevOps. But before we begin, we should probably level set, right? Because what exactly is DevOps? You ask 10 people, you're going to get 20 different answers. At Microsoft, DevOps is something very specific to us. DevOps is the union of people, process, and products to enable the continuous delivery of value to our end users, right? So again, I said this very carefully because every word has meaning, right? I didn't say continuously deliver code because what will that give us? Piles and piles of code sitting on a source control server somewhere, who cares, right? And I didn't say continuously deliver features because again, I could be delivering feature after feature, sprint after sprint. But if this is not what my end users need or want, why am I wasting the time, right? So what's important is we have to continuously deliver value. So some of you might be wondering, why is this important? Why do we need to continuously deliver value? The bottom line is the speed of business today is so ridiculously fast. The only way engineering teams can keep up is and innovate fast enough is if they adopt DevOps best practices. Here's the thing. If you don't adopt DevOps best practices, your competitors, they either have or they will. And once they do, they will out-innovate you. And once they out-innovate you, what happens? Now you become obsolete. And none of us wants to be obsolete. So this used to be DevOps theory, right? I've been talking about DevOps for about 7 years or so. So we've been doing this forever now. But we've been doing DevOps long enough where this is no longer theory. We know this to be true. We have empirical facts. We have numbers that show beyond a shadow of a doubt. Teams that adopt DevOps best practices absolutely out-innovate teams that don't, right? So this is why it's so important to adopt DevOps best practices. However, it's not easy to do, right? You really have to concentrate and make sure you tackle all three of these pillars: the people, the process, and the products, right? The people, this is a cultural shift, a cultural change that needs to occur within your organization from the very, very top all the way down to the very bottom, where everyone must be hyper-aligned, hyper-focused on continuously delivering value, right? So this is a major cultural shift that has to occur that is extremely important. The process, that's actually pretty easy. You need a process that will let you iterate fast enough, yet still deliver code of high enough quality. So basically, any type of agile type of process, those work great. And finally, you need to have products that can help enable all of this, right? So right about this time, this is usually when I show a demo. And my demos are usually all rainbows and unicorns, right? Because they're flashy and they're great. It's some Hello World application. I go ahead and check code in, and next thing you know, builds kick off, tests run, automated UI tests are running, and it flows through a pipeline and lights are flashing, and bam, the change shows up in production. Yay, right? Except it's not very real world-like, because it's just a Hello World application. In the real world, things are very different, right? In the real world, DevOps looks a little bit more like, well, something like that. It looks like a dumpster fire, right? We try something, things break in ways that we can't even imagine until we start running it. Sometimes things are working, and then all of a sudden, for no apparent reasons, they start breaking, and then you look at it, then you realize, oh, it's because we changed out these passwords over here, blah, 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 right? So real world DevOps is a lot messier. So what I wanted to do today was to use a real application and show you real world DevOps using DevOps best practices. So for my real world application, I'm going to use a modern microservice-based app, which basically it has an ASP.NET web front end, and this is a old school ASP.NET, right? Not .NET Core, old school ASP.NET web front end. We also have a SQL Server database in the background. We also have a REST API that's written in Node. This is going to be running in a Kubernetes cluster, right? So it's hosted in containers, running in a Kubernetes cluster. There's also a services layer that's written in .NET Core, and this is going to be running as a Docker container. And I also have mobile applications for this as well, iOS and Android. So this starts bringing up some real world problems in my applications as soon as I started building out my pipelines. First of all, my application is not ready for real microservice deployments. What do I mean about that? The best thing about having a microservice architecture is you don't have to deploy the entire application if you make one change to one microservice, right? Because they're all, there shouldn't be any dependencies. So I was like, great, this is going to be fantastic. I'm going to build out like 5 separate little tiny pipelines. This is going to be a really cool demo. Hooray for that. And that worked 2 times. And then things started breaking. The reason is because even though I've teased out my monolithic application apart and turned it into microservices, my microservices still have dependencies among each other. So microservice A depends on service B. So now the order that I start deploying my application starts to matter. But things got even more complicated because service A depended on service B, that depended on service C, that now depends on service A. Uh-oh, now what do I do, right? Because I have a circular dependency, there is literally no way for me to deploy this now without getting some type of downtime. So what do I do about that? Well, there's got to be a way we can somehow figure this out, and we'll figure this out in a minute. The next problem that I ran into is the infrastructure is extremely painful to spin up, right? Because I need to do a lot of tests. I need to spin up my environments a lot. I need to tear them down. We're looking at Azure App Service. We're looking at Kubernetes clusters. We're looking at storage accounts. We're looking at Azure Functions. We're looking, so on and so forth. These are a lot of different assets that we need to spin up and configure. And that takes a lot of time to do all of that. It takes me about an hour to actually bring up the entire environment up and get it all configured. Got to be a better way to do that than doing all of this manually, right? Next, my microservice architecture is difficult to join under a single URL. And the reason is because I'm using microservices in the background, when they try to communicate with each other, it gets really messy. I start getting cross-domain issues, right? CORS issues. And there's extra code that I could write that would take care of this, but is there a way that I could fix this easier than writing more code? We'll look at that as well. Other things I need to worry about database. I have a SQL Server database, right? So how do I do database DevOps? And how do I do mobile DevOps? Is that even possible? How do I maintain quality, right? Great, I have these pipelines that are wonderful. I check in code and it can flow all the way out into production in like 15 minutes or so, but am I just pushing bugs into production like crazy now? How do I maintain quality? And same with security. Am I just pushing security holes into production at a crazy, crazy rate? So we'll look at that as well. And finally, because this is a real world application, I have to worry about things like DNS and HTTPS as well, right? So these are some real world problems that we run into when we start trying to DevOps real world applications. So how do I fix all that? And the answer is what I like to call DevOps Nirvana, right? Guess what? I can literally build out a pipeline that does everything that I need. And it makes my life really simple. And all I need to do is just push one button. Now, my demo happens to use Azure DevOps Services. You don't have to use Azure DevOps Services, right? Everything that I'm showing, these are just DevOps best practices, which you can use any tooling to do, right? All right, so enough of me talking. Let's dive in and take a look at what I did. All right, let me bring back my browser. And it looks like I see a lot of green, which is good, and the deployment still isn't done yet, so I'll just keep talking. All right, so everything, well, first thing that I want to tackle is what about my microservices and their dependencies? There's ways for me to solve this, but that means I have to add extra code, right? Basically, first of all, I have to make my services truly independent, where there are no dependencies among them. Only then can I treat them like a real microservice. Until I do that, the scope of my dependencies is the scope of my pipeline, which unfortunately, since there are dependencies, I have to treat my application like a monolith until I really tease apart my services until there are no dependencies. And there's a couple different ways that we can do that, right? But at this moment, I have to treat everything like a monolith. So if I make any changes, what needs to happen is everything starts with my build, right? So here's my build pipeline. I'm using a visual editor to show what's going on instead of YAML because a visual editor looks so much nicer than a wall of YAML. But again, usually I do everything in YAML. I check it in. But I have an agent that's going to build my web front end, and it's going to be a Windows agent. This is going to build my web front end. So remember, this is written in ASP.NET. So I restore my packages from NuGet. I scan all of my packages using white source bolt. What is that? This is a security scan, right? So what I'm trying to show is you can start adding security into your pipelines, right? You're shifting left. So instead of trying to bolt on security at the end, you're going to start doing all of your security early. You're going to start doing it within your pipelines as well. One of the things that I'm doing is white source bolt, which is going to scan all of my source code, looking at all of the open source libraries that I'm using, looking at what versions I'm using. And if I'm not using the latest and greatest version, it will catalog that up. It will let me know, and it will let me know what type of security holes I have in my application because of this, right? So this is just one example of security scanners that you can add. There are literally hundreds of them, right? So if we jump into the marketplace and we search security, you can see pages after pages after pages of security tools. There are fuzzers, there are hackers, there are all sorts of things, right? There are scanners that looks for leaks, leaking credentials, things like that as well. So all sorts of great tools that you can use. All right, next I build my solution using Visual Studio. Then after that's done, I run all of my unit tests. Again, how do you maintain quality in a DevOps world? You can't tap quality at the end of your application by doing full end-to-end functional testing anymore. You just don't have time to do that, right? So how do you do that? You shift left. So you start building quality into your application as you're writing it with things like unit testing. In fact, I wanted to show this as well, because this is actually kind of neat. This is the quality dashboard of Azure DevOps Services itself. If I dive in here, looks like it's refreshing. Hold on. If I dive in here, this is our real production data. So let's jump into a pull request. We'll just grab any one of these. And every single check-in has to go through a pull request, right? So this is our policy at Microsoft. Every single check-in has to go through a code review. And one of the things it does is it's going to build the application and run all of our T0 and T1 tests, right? So these are our unit tests where there are very little, almost no dependencies to just one dependency, right? So these are things that can run in our builds, and they can run very, very quickly. If we look at this, every single developer check-in has to go through, at this moment, 28,166 tests, right? Let me say that again, because it's so mind-blowing. Every single developer check-in has to pass over 28,000 unit tests. And we run all of these in less than 3 minutes, right? How do you maintain quality in a DevOps world? This is how we do it. All right. So once the front end is built, I go ahead and package everything up so it's ready to be deployed. Next, in parallel, I build my iOS application. There's really nothing magic about this, except I use a Mac to do that. Also in parallel, I build my services layer, right? So this is in .NET Core, and I package everything up as a container, because remember, this is going to be running in a container. And then also my API layer, this is written in Node. So I build it inside of a Docker image. And then because I'm going to deploy this into a Kubernetes cluster, I turn this into a Helm package, right? All right, so far so good. Now, once that's done and everything works, this gets pushed over to my pipeline, right? My deployment pipeline. So let's go ahead and jump into my deployment pipeline. And I deploy everything using this. Kind of scary looking, right? Because it does a lot. So we'll kind of walk through and talk about everything that it's doing. First, the first thing that it does is it goes and it deploys a set of tools into Azure that I use to help me deploy the rest of my application, right? So what is the set of tools? It's actually a set of Azure functions. And it's also Azure storage as well, right? And what is it actually? Why do I need these tools? Here's what it's actually doing, right? There's a DNS checker, there's an infrastructure version checker, and there's some stuff that I need to do for my mobile environments as well. So these are functions that needs to be called. The DNS alias checker, this is kind of neat. One of the things that I need to provision, right, in Azure is called Azure Front Door. It's like an Uber load balancer. I literally cannot provision it, let alone configure it. I can't even provision it until the DNS settings that I want to use has propagated all the way down to the local machine, right? Why does that happen? I have no idea why that happens. But because of that, I need some way to be able to check to say, hey, did DNS flow all the way down locally yet? So that's what this function does. But there's a whole bunch of other little things, other little tools that I need to do. So some of you might be thinking, okay, this is kind of neat, but didn't you show that you had absolutely nothing in Azure because some idiot deleted everything? I deleted everything, right? And the answer is yes, but I don't care. It doesn't matter because in my pipelines, I use DevOps best practices. I use infrastructure as code, where the infrastructure that I need is completely described and stored in source control. So the first thing that it does is it starts provisioning the infrastructure that I need, right? And then it deploys out everything that I need. So how do I do that? First thing that I do is I decrypt my secrets from Key Vault. So I store all of my secrets in Key Vault. Why Key Vault? Because Key Vault's freaking awesome, right? It's a centralized place, centralized and secure place that I can store all of my secrets. If I need to rotate my secrets, I can do it in one place and it just magically propagates into all of my pipelines that use them. It's a fantastic tool, highly recommend it, right? Next, I go ahead and provision and configure my tools. Remember, I'm using infrastructure as code, right? So if you're talking about infrastructure as code in Azure, you're talking about things like ARM templates, Terraform, Poloni, things like that, right? I happen to be using PowerShell script wrapped around the Azure CLI. Why? Why not? Because that works as well, right? So there are lots of different approaches that you can use for infrastructure as code. Personally, I don't care what you use. I just want you to use infrastructure as code. All right. So I provision what I need, which is going to be a bunch of storage and Azure functions. Then I deploy my application, my tools, my Azure functions into this Azure function that I provision up in Azure. So when that's finally done, then I fan out, right? And in parallel, I start provisioning all the infrastructure that I need for my real-world application. Let's go ahead and look at the web first, because that's easiest to understand. Again, same thing. I decrypt my secrets from Key Vault. Then I go ahead and provision my web. I know it says web and database, but in this case here, it's only provisioning my web, and it's configuring it as well. So it's provisioning an Azure App Service. How is it doing this? Again, it's using infrastructure as code, and I'm using PowerShell script wrapped around the Azure CLI. Again, you can use the ARM templates, you can use Terraform, or you can do what I'm doing here. How you do it is less important than just use infrastructure as code, right? So if you're curious, here is how I'm doing it. Remember, this is just a PowerShell script wrapped around the Azure CLI. So the first thing that I do is I pass in a bunch of parameters that I'll be using in my script. Then it's just calls using the Azure CLI. I log in using a service principal, using the Azure CLI, and then I create my resource group, and then I go ahead and I start doing my stuff, right? I create an app service plan, I create my Azure app service, I start doing configuration, so I start setting up my connection strings and things like that. And I start doing all sorts of configurations that I need, not just provisioning, but also configuring as well, including setting up application insights, so on and so forth. So pretty simple, right? All right, so let's jump back to our pipeline. In parallel, and when I'm finally done, what do? Provisioning, I go ahead and deploy my Azure App Service into the app service that I just provisioned and configured. All right, so in parallel, I'm also doing a lot of stuff. Let's look at what I'm doing with my database, because this is kind of cool. Decrypt my secrets from Key Vault, hooray for that. I go ahead and provision my database, right? And when that's done, I deploy my database schema using SQL Server Data Tools. So remember we talked about database DevOps. Can you do it within your pipelines? Absolutely. You can do it using tools like Redgate, or in my case here, I'm using SQL Server Data Tools. There's even things like Lookatbase and Sybase and things like that. Other tools, open source tools that lets you do database DevOps right within your pipelines. What's interesting, when I go ahead and provision and configure my database, let's jump to that, because that's actually kind of cool. I do a couple of things. Again, this is using the Azure CLI, so I pass in a bunch of parameters and I log in, and then I go ahead and provision and configure my SQL Server. But the other thing that I do is I know that if I run this, right, and I'm provisioning a brand new SQL Server database, what that means is something really bad has happened and my SQL Server database disappeared or cratered for some whatever reason. I don't know what it is, but there's some reason, right? The cool thing with Azure SQL is it automatically takes backups and it stores it in a whole nother subscription. So my thought was, if I have to provision a brand new database, why don't I go to my database backup storage and restore from backup? Because now, guess what? My pipeline is also doing disaster recovery. So that's what it does. Not only do I provision and configure my database and lay on a brand new schema, the schema for the database, if I'm provisioning a new database, it will go ahead and restore from backup as well. So my pipeline does disaster recovery. All right, I thought that was pretty cool. Let's jump back. Other things that I do, my API layer. Remember, this is with the Kubernetes cluster, right? So this, I go ahead and decrypt my secrets from Key Vault, and then I go ahead and deploy my Kubernetes cluster. This time, I use an ARM template. Why am I using an ARM template? Because I can, right? I wanted to show that infrastructure as code, again, you can use whatever infrastructure as code that you want. You want to use ARM templates, hooray. You want to use Terraform, that's great. You want to use a script wrapped around the Azure CLI, that works as well. Again, how you do it is less important to me than that you use the right concept, which is infrastructure as code. All right, so it provisions a Kubernetes cluster for me, it configures it, and then I go ahead and install my API layer by using Helm. So I deploy my Helm package into my Kubernetes cluster. Other things that I do, I go ahead and deploy my mobile app. Guess what? You can do mobile DevOps, and I use App Center to do that, which is a Microsoft product. There are other products that you can use as well that will go ahead and deploy your mobile application to whatever groups that you want and bypassing the store. So you can deploy it to your testers first, so on and so forth. App Center is a great Microsoft tool that does that, so I do that, right? But again, the real tooling that I use is less important than the concepts that I'm showing. All right. And I also set up DNS, right? How do I set up DNS? My DNS settings, they are held up in Cloudflare. So what that means is I can set up my DNS by using REST API calls, which is exactly what I do. I decrypt my secrets from Key Vault, pass those secrets into a script. All this script does, it's not magic, it's just calling REST APIs to Cloudflare that will go ahead and set up my DNS settings for me. All right. When that is all done, it funnels on over, and I now go ahead and deploy my front door instance, right? What is front door? Remember, that is an Uber load balancer. But before we do that, remember earlier when I said I can't even provision front door until the DNS settings that I need has propagated all the way down locally. So what I do is at the end of it, I have a post-deployment condition, right? So let's jump to the real live deployment because I can show it there. All right. So I have a post-deployment there as well, right? So what that does is after I set up my DNS settings in Cloudflare, I have a post-deployment gate, right? So of course, we all understand automated deployment gates. Manual deployment gates, which is a physical person or a group of people have to come and say, yes, it looks good, I approve before it goes on to the next stage, right? You can also create in Azure DevOps Services, you can also create automated gates where it uses automation to help you determine, should I go on to the next stage or not? So what this automation does is when you set up this automation, you set up, okay, what's my polling frequency? And in this case, I set up, what is the Azure function that I call, right? So I call my DNS function checker. Why? Because every 5 minutes I'm checking and I'm asking, hey, did the DNS settings flow down locally? And if it did, let's go on to the next stage. And if it didn't, let's pause and let's wait 5 minutes, right? So that's how I'm doing that check. All right. So once my DNS settings have flowed down locally, that's awesome, right? Now I can flow into my front door, right? So when I started with my infra tools, I fan out, and in parallel, I provision and configure and deploy all of these things that I need out in Azure. Then now I fan back in, right? And I create my load balancer that's going to sit in front of all of the resources that I provisioned. Right, so what am I doing in here? Again, nothing magic. This is just the same type of things, right? I decrypt my secrets from Key Vault. I go ahead and provision front door using a script, and then I add HTTPS because now everything is in place. my load balancer has been provisioned, so I can add HTTPS to it. How do I do that? I need to add my certificate, right? Luckily, guess what? All of that can be done using the Azure CLI. So that is literally what I do, right? Using the Azure, again, I use a PowerShell script wrapped around my Azure CLI calls. Why am I using PowerShell? Because I happen to know PowerShell really well. Could I use Bash scripts? Absolutely, you can. But if I use Bash scripts, I'd have to be Googling a lot, right? Which would mean it would take me a lot longer to build out this demo. That's why I use PowerShell. Again, the physical technology that I'm using is far less important than the concepts that I'm trying to show. So what am I doing in this script? I pass in a bunch of stuff. Then I go ahead and use the Azure CLI to set up HTTPS, upload my certificate, so on and so forth. All right. Jumping back to my application. Once front door has been configured, right? I do a couple of things now. Again, in parallel. So I fan out and I do two things in parallel. I run a bunch of automated UI tests against my environment because after I've configured and deployed my front door instance, what that means now is that my entire application has been provisioned, configured, and deployed. So it's now ready to run, right? So at this point, this is when I'm going to add a bunch of automated UI tests to test my application. And I do the same thing for my mobile app as well, because by the time front door is set up, that means my mobile app is ready to be tested as well. So in parallel, I do automated UI tests for both my web front end and also my mobile application. How do I do that? Let's jump in and take a look. Decrypt my secrets from Key Vault, and here I run a bunch of Selenium tests, and that's it. All right, what is this AZSKSVTS task? What's that doing? That's actually a security scan, right? Why am I doing a security scan right here? I could do it in other steps, but I kind of threw it in here just because it's as good a place as anywhere else. Again, right now, my entire infrastructure has been provisioned out in Azure, right? So this task, what this does is it checks Azure policy, and which can be configured. And if I am breaking my Azure policy in any way, shape, or form, maybe when I deployed my SQL Server database, I forgot to do everything using HTTPS. And because of that, I'm breaking policy, right? And if I'm breaking policy, it's going to flag it here and immediately stop my deployment right here, right? So what I'm trying to show, again, is not necessarily this specific task. What I'm trying to show is you can start adding security into your release tasks as well. I showed that you could add security tasks in your build. Guess what? You can shift left over here as well and add security tasks in your release pipelines as well. Inside of here, this is kind of neat, right? If you start looking at, remember we went into the marketplace and we saw the hundreds and hundreds of security tasks. You can add all sorts of stuff, right? You can add automatic hackers. You can add fuzzers. You can add hackers that will try to just automatically do SQL injection into all of your forms and try to find this for you. You can have, fuzzers that automatically try to hack your application. These are all things that you can add into your pipelines so you can add security, right? If we no longer have time to do end-to-end security checks by doing auditing of hundreds of thousands of lines of code once the project is done, because that takes months and months of time, how do you maintain security? You shift left. You start building security into your applications, right? So this is one of the ways that you can do that is by adding security tasks into your pipeline, starting from your build all the way out even to when you're deploying. All right. So in parallel, I go ahead and deploy my mobile application as well. Not only deploy my mobile application, I'm going to go ahead and test it using automated UI tests using App Center. So App Center not only does it do deployments for you, you can also run automated UI tests, and it also collects a whole bunch of telemetry for you as well. So I do that all within my pipeline. So here comes the neat part, right? Because by the time I'm done doing my automated UI tests for my web and also for my mobile application, then it goes ahead and fans back into this stage, which is beta done, right? This task, notice it doesn't do anything, right? But it does have a manual approval gate right here. Because when it finishes to this stage here, what that means is my entire application has been provisioned, it has been deployed, it has been configured. I've even run automated UI tests. Now I want a human set of eyeballs to take a look at this to say, hey, does this look okay? And if it does, they can approve it. And once they approve it, it goes on to the next stage, which is my real production environment. So my first stage is my beta environment. My second stage is my production. And then it flows and it fans out and it does the exact same thing, right? Except now this time it provisions and configures and deploys into my production environment. All right, so if we jump back into our real deployment, you can see that the deployment was successful. And now it's waiting for a manual approver. Did I deploy, provision, configure, and deploy successfully? I don't know. Let's see if this worked or not. If I go into my Azure resource group and I refresh, I have a new resource group. That's good. And if I go into this resource group, I'll be able to see I just provisioned all sorts of things, including my Kubernetes service, app service, functions, SQL Server databases, storage, so on and so forth, right? So that's a good sign. But the proof is if I come to my real application, let's go ahead and refresh this, and bam, there's my application. It has been provisioned, configured, and deployed. But wait, there's more, right? Remember, we said, or I told you that my pipeline, not only does it bring back to life everything, even if I deleted everything within Azure, right? Because I'm using infrastructure as code, I'm also doing things like disaster recovery. So if I click on exercises, this should bring back a table of all the exercises that I've been doing. If it brings back an empty table, that means I did not do disaster recovery, right? But it brought back stuff. It brought back data. Why? Because remember, my pipeline, if it notices that there's no data, it's going to go to backup and automatically restore as well. So this pipeline does disaster recovery, which is ridiculously cool. Right? All right. Last thing that I want to show you guys. Notice this little lock icon is in the lock position. Why? Because I set up HTTPS, right? I set up HTTPS within my pipeline. And finally, let's look at this particular URL. This URL here is not using an Azure URL. It is literally using a URL that I selected because I set up my DNS. So guess what? This is a real-world application doing real-world things, real-world DevOps. So I hope this was useful for everyone. I know I kind of went through all my details very quickly, so I provided a bunch of resources for everyone, right? If you have questions, go ahead and tweet me at Abel Squidhead. And if you want to know exactly what I did within my pipelines, I have great blog posts that will walk you through step-by-step everything that I did. All right, thank you all so much.
Thank you very much, Abel. So we do have one question here in the Pine Tool chat.
Sure.
Anyone else got questions? If you get them in here quick, we can probably answer them. Otherwise, take it to the discussion room afterwards. Question, what are the best practices for long-lasting requests, e.g. Deploying new versions, draining connections, cooldown period, cache TTLs? Okay, hang on. Sorry, he said, what are the best practices for long-lasting requests? E.g., draining connections, cooldown, cache TTLs makes deployments lower risk, but takes longer time. What's your kind of opinion on the trade-off there?
Yeah, it's always a balancing act, right? Because it's like, okay, sometimes things will take a really long time versus, how safe it is. But, at that point, you need to start measuring out things like, okay, if we don't do these steps, what is the danger involved? Because if the answer is really bad things could happen, you know what? If this takes an extra 3 hours for the pipeline, it's kind of worth it, right? So as an example, Azure DevOps Services, we use Azure DevOps Services to deploy itself as well. Our deployments, when we press that button, it takes so long, it literally takes a week to deploy until it hits the entire world, right? And I'm not bragging because that's way too long. But the reason why is because Azure DevOps Services is a service that can never, ever go down, right? This holds people's source code. This holds people's pipelines. This holds how they track their work. If we go down, other companies can't do their business. So we can't go down. Because of that, our pipelines are very, very resilient, right? And they take a very long time because we're very careful and deliberate about what our pipelines do. So for things that take a long time, you do have to balance it out. But I tend to err on the side of I don't mind if my deployments take a very long time because they need to work 100% of the time all the time. But sometimes that might not be the case. So like anything else in our industry, it depends.
There's always an interesting thing that the deployments that you do on purpose can take as long as they want because they're part of a plan. It's when you find something broken in production that everyone suddenly wants to go live right now.
Yes.
And if you can avoid those things happening, then the emergency deployments are no longer a consideration.
They're no longer a problem. And then I know people love to bypass the process for emergencies, right? But that's the wrong thing to do because during an emergency, that's when you need your process more than ever because your process, that's what protects you. I know we've all tried to put out fires before. We pushed to production, and now we just introduced a way worse bug than ever before. Now we're leaking credentials or something, right? So I know we love to jump into production and just make those changes, and it's just going to be that one time, but that's the most dangerous thing to do.
Cool. So another question in the chat, following this example, are you testing the production environment?
Are you testing the production environment? Yes, absolutely. Why wouldn't I test my production environment? So
well,
one of the
that's what
things
customers were for, right?
So testing in production is a very, very real thing. And no matter what we do, we're going to be testing in production, whether you think you are or not, because even if we can duplicate our environments, our testing environments and our production environments, they're not going to be the same because the traffic is not going to be the same. No matter how much you try to make it the same, they're not, right? So you are going to be testing in production. Why don't you test in production in a controlled way instead, right? So if you do things like feature flagging and testing in production, you can do it in a much safer manner.
Cool. And finally, someone's just said, so a lot of thanks in the chat, lots of thumbs up, very, very well received. Final question, how do you manage to run all the 20,000 tests in only 3 minutes?
Aha, very good question. So these are L0 and L1 tests, right? So these means there are very little dependencies. In fact, L0 means there are no dependencies, which means all outside systems are mocked, right? So your database is mocked, your service calls are mocked, everything is mocked. These are true classic definitions of a unit test. L1 test means there's one layer of dependency. So it might depend on Azure AD, or it might depend on a file system. But again, these are things that can run without deploying an environment out, and it can run very, very quickly. We have tests that run all the way out to L5, right? And L5 is a full-blown integration test where the entire system has to be out before you can run those tests. And those, of course, run ridiculously slow. So that's one thing, is we only run L0 and L1 tests. The other thing is we spend effort grooming our tests to make sure they run quickly, right? So at the end of every test, we have a rule that says no matter how many tests we run, it must be under 8 minutes. And if it ever gets close to 8 minutes, what we do is we start looking at all of our tests, and we look at what are our long-running tests. And then we look through it and say, why are they long running? Because they should take milliseconds. And if they are not taking milliseconds, why not? What are we doing wrong? And oftentimes it's because, oh, you know what? We coded up this test badly. We can do the exact same thing, do it more efficiently, and run it in milliseconds versus minutes, right? So by constantly doing that, we're able to run our tests extremely fast.
Cool. We just have one more question before we end the session here. It's from Danny. It says, a difficult question for a dev, Azure DevOps or GitHub Actions?
Oh, do I use GitHub Actions or Azure DevOps? Is that the question?
So the question is, when running OSS on GitHub, so I'm guessing it's, what would your recommendation be for someone maintaining an open source project that's hosted on GitHub?
Aha, fair enough. Again, it depends, right? If you are in GitHub, I would just try Actions because Actions are fantastic, right? They're awesome. My only issue with Actions at this moment, today, right, which is what, November 11th, It doesn't do CD very well. It doesn't do continuous delivery very well. It does continuous integration. It's fantastic. But it doesn't have features like approval gates, right? And there are ways that I can work around it, but they're kind of hacky, right? So if I need more enterprisey, advanced DevOps type of stuff like approval gates, I wouldn't use Actions. I would use the integration with Azure DevOps, because Azure DevOps is so full-featured, you can do everything you can. But if you don't need those features, I would use GitHub Actions, because they're freaking fantastic. And soon, I can't say when, but soon, just stay tuned, people, that's no longer going to be an issue, right? Because Actions are going to have all the features that you need, even in a enterprisey, DevOpsy type of world.
Fantastic. All right. We're going to wrap it up there. 13:30, right on the nose by my clock. Thank you so much, Abel, for sharing. Thank you, everyone, for joining in, watching. We're up to 285 people on the stream here. So you got to imagine you got 280 people all applauding right now. Thank you, everyone, for tuning in. We are going to take a very short break. We will be back very shortly. Enjoy Build Stuff. We'll see you in a few moments. Goodbye.